First thing to say, Ted, thank you for convening this meeting, which is very timely, I think. Just to add to your introduction, so I work for a business called JBA. We specialise in environmental risk management, and specifically around flood risk, based in the UK but international. Around about 80% of my time is seconded out of our commercial business as director of an independently governed charity that we established 9 years ago called the JBA Trust. And I also have an affiliation as a professor in practice at Lancaster University, as you mentioned. I said that I thought this meeting was timely. There's several reasons for that. One of which is, of course, that around the world at the moment there are, there are numerous people who are suffering from the effects of flooding. There's been flooding recently in the US, for example, and also in East Africa. And of course, if we rewind to earlier this year from a UK perspective, if we're able to look back beyond the onset of the coronavirus outbreak, of course, there were numerous communities flooded over the last winter in Britain, and some people who are experiencing flooding for the second or third time. So clearly the risk of flooding was materializing and being felt by people in the real world, only very recently here. And of course, flood risk has a long tail. So individuals, households, businesses that were flooded earlier this year will still be suffering from the after effects, as indeed will some who've been flooded in previous years. Any progress with the slide pack, Ted?
My guess is it might be too large to have come through the email, because I'm still not seeing it. You can try and send it to my Gmail account. That might be a little more forgiving on size. Oh, it just came through, so maybe it is too big. So yeah, keep going, and I will get it set up.
Okay, great. Okay, thank you. Okay, so I guess that another reason why the meeting is timely is, and when you have it, my first slide will show this. From a UK government perspective, the high level planning for risks is conducted through something called the National Security Risk Assessment. The National Risk Assessment expresses a high-level view of threats to the United Kingdom. Okay, so it's slide 3 there. Okay, back one, please, Ted. Yep. Okay. So the diagram here, which is taken from the public-facing version of the National Risk Assessment, shows threats to the UK expressed in a likelihood versus relative impact matrix. You can see that quite clearly pandemic flu, and obviously COVID is not quite the same thing as flu, but a pandemic disease has for some time been flagged up as both one of the most likely and highest impact threats to the UK. Somewhere just a little bit behind that, and a little bit further down the list, is a cluster of 3 types of flood risks. So there are 3 flood scenarios considered within the National Risk Assessment: one for flooding from rivers, one for flooding from the sea, and one for surface water flooding linked to intense rainfall. So clearly we already appreciate flood risk to be one of the most important risks at a strategic level. And I think that, in many ways, some of the debates that are playing out very acutely at the moment relating to coronavirus in terms of our shared understanding of risk and resilience and communication, reporting, trust in institutions and experts, and the kind of social contract between citizens and the state. Those things are really obviously very intense and very acute at the moment. But I think there are many parallels. Many of those, many of the things that we're seeing at the moment resonate when we think about flood risk. So if you could move on, please, Ted, to the next slide. So I've been working on flood risk analysis and resilience for more than 20 years now. And something that has struck me throughout that time is that, every time we experience nationally significant flooding, almost every time it seems that somebody somewhere will refer to the events that we experience as being unprecedented. And I think that, well, in a technical sense, that might be true at times, and I'll come on to that in a moment. But I think that there may also be, perhaps psychologically, some kind of sense of plausible deniability here, in that, if something is truly unprecedented, then perhaps we can avoid a sense that we should be able to prepare for it and respond to it. If you can move on to the next slide, please. I guess it's important to recognise that flooding and really severe flooding in the British Isles is not new. Going back over millennia, and clearly, the estimates of what happened in these events and the evidence for them is quite uncertain when we look back a long way. But we have studies that show that there have been seriously damaging floods over the last 1,000 years or so. In some cases, there may have been tens of thousands of people who were killed in those floods. And if you can move on, please. And more recently, thankfully, loss of life is comparatively rare in flood events, and certainly since the 1953 coastal floods on the east coast of Britain, that has been the case. But I guess we've become more and more aware and able to quantify the economic cost of floods, and those costs are significant and they're mounting up. This table, of course, does not tell the full story about the cost of flooding, and we'll come on to that in a minute. And there's an important debate to be had as to how we represent the impacts on people in this kind of risk analysis. So you can move on, please, to the next slide. So I said that it may be true in a sense that some of the floods we've experienced are unprecedented, and I think in a narrow technical sense that can be correct. So I've got a map, 3 maps here showing 3 of the most significant recent large-scale flood events in the British Isles. What you can see here is a coloured dot indicating the relative extremeness of the river levels during each of these 3 events, and the dark red coloured dots represent measurements that were in the top 3 historically at each of those locations. So in effect, those dark coloured dots contain measurements on rivers where it's likely that the river levels were breaking historical records when the flood occurred. And as you can see, across those 3 events, there were record-breaking or close to record-breaking river levels across most of the UK at one time or another. So yes, in a sense, during those events, it might be right to say that river levels were unprecedented. But of course, when we look at the overall picture, the numbers of people and properties that were flooded and the damages, clearly we shouldn't be surprised when this kind of thing happens. Could you move forward, please? Okay. So we can put a bit more precision on that and use statistical models based on observations of rivers to come to an understanding of how likely flooding is. In this case, it's England and Wales, so my apologies to compatriots in other parts of the UK. For technical reasons, this analysis was only done within England and Wales. On the map there, you can see each dot there represents a river gauge that measures river levels. And we, working with colleagues in statistics at Lancaster University and with the Environment Agency, we ran some analysis here to look at the likelihood of a flood occurring, an extreme flood occurring somewhere across England and Wales in any one year. And it turns out that the probability of that happening is about 80%. I won't go into detail on what the graph shows, but what we were analysing there is the chance of seeing a river level somewhere in England and Wales in any year that would almost certainly overwhelm local flood defences if they exist in the location that the high river level occurred. Although the event that's being considered here might be quite rare locally, with a 1% annual chance, it turns out that we should expect to see something like that happening somewhere in England and Wales each year with roughly an 80% chance. So I think, we have to be pretty clear from this that flooding and even quite extreme flood conditions are not at all uncommon. So if you can move on, please, to the next slide. So the question is then, where is at risk? Where would these floods happen? When, and if and when they occur? And in the United Kingdom, we have quite detailed mapping of flood risk. This is the product of a long-term investment in data collection and modelling, and also communications through things like the .gov.uk website, and the maps that you can see here are also similar products are available throughout Europe as a result of the floods directive. These maps are quite detailed. They express flood risk at a level that picks out individual streets or properties. They're available ubiquitously. They're in the public domain, and importantly, they're also discoverable. So it should be fairly easy to find this information. They are good, I think, in the sense that they use a lot of very detailed data, and a great deal of effort goes into the technical analysis that sits behind them. They're also not perfect, but there is a commitment for maps like this to continue improving over time. There are also similar products that have been developed by the private sector, largely driven by the needs of insurance companies that play a similar role for risk analysis, mainly by commercial businesses. So if you could move on, please. So from our mapping, we can do some kind of risk assessment in quantitative terms. Now, there are slightly different methodologies applied in the different regions of and nations of the UK. So it's not entirely straightforward to tie all this information together on a UK-wide basis, but one attempt to do that has been as part of the climate change risk assessment, The latest published version dates from 2017, although there's a new CCRA being prepared at the moment. And based on the data compiled within the CCRA, which draws on official government sources from around the UK, you can come out with an estimate of total economic cost of flooding at something just under £2 billion on average per year. And there are a number of different estimates of this that vary slightly depending on the methodology used, but the results are generally somewhere in the £1 to £2 billion range as an annual average. There are also substantial parts of our national infrastructure that are at risk, and many people, of course, 1.8 million people around the UK, of whom some 320,000 live in what would be classed as deprived areas. And also thinking again about the current situation with the virus outbreak, well over 1,000 hospital, care home and medical facilities at risk. Now I keep saying people and properties at risk here. It's important to quantify what that means, to be clear about what we mean by at risk. In this case, there is a technical definition, which is a location, a place that has a chance of flooding of more than 1 in 75 in any given year. And that's based on the current present day climate. 1 in 75 might not sound like a very high probability, depending on one's perspective and tolerance of risk. But if you think about what that means over a longer period, so let's take, for example, 25 years, maybe typical of a mortgage loan, that translates to almost a 1 in 3.5 or nearly 30% chance of flooding over a 25-year period, if nothing else changes. So that's a calculation based on a false assumption that the world is not changing and there are no increases or decreases in risk over that 25-year period. So if we could move on, please. So I've been talking a lot about quantification and numbers here, but of course it's important to recognise that those numbers really don't tell the full story. We talk for technical reasons about things like residential properties in order to distinguish residential homes from businesses or other types of property. But of course, a residential property is a home. It's somebody's home, it's where they live, and flooding to people's homes, of course, is a very personal thing. And the impacts of flooding on health, on mental health, on well-being, I think are becoming increasingly well understood, but are quite hard to capture in quantitative terms. There's also a very important set of stories around local and personal resilience that are not apparent in the headline figures, and perhaps there are some positives there about the ability of communities and people to help themselves, and perhaps also with the support of national agencies and regional agencies to be resilient. And there is, I think, an important discourse that we need to have about what the contract is between citizens and state here, and what our expectations should be. There is also, I think, an understanding and a growing realization of the complexities and importance of our dependency on various types of infrastructure systems. The picture in the bottom right here, this workshop has been convened through Lancaster University. Those in Lancaster will perhaps recognise this as the substation on the River Lune that flooded in December 2015, leading to an entire city losing power. That was a real wake-up call, I think, in terms of our, the complexities and the risks that can materialize when flooding disrupts infrastructure networks. And it's a very sobering thought to imagine what would have happened if another such power distribution asset had been flooded somewhere else in the country at the same time, which is not, that is a plausible scenario, and whether we would have had sufficient mobile generating capacity to handle such a scenario. If we could move on, please. So I've been talking about risk in the present day, or risk in the current climate, which in effect means our risk analysis based on data from the recent past. All of this begs the question as to whether flood risk is increasing, and there is evidence. I'm looking here at data relating to river levels and data relating to sea level rise. There is evidence that there are increases and have been, and that these hazards have been increasing over the recent past. The sea level picture is really quite clear, with a rise of around 15 centimetres on average around the UK over the last century. There are some regional variations around that, but that's the average figure. For rivers, things are a little bit more complicated because of the variability of weather patterns and of hydrological processes around different parts of the UK. But there is evidence of statistically significant upward trends in high river flows, certainly in the west and towards the north of the British Isles. So this is a retrospective analysis, giving us some historical context. If we could move forward, please. Our understanding of these increases and of global warming means that for probably the last 20 years or so, when I think almost every time we have a nationally significant flood event, somebody asked the question as to whether it was in some way linked to climate change. I first experienced this after the floods of winter 2000, which were very widespread and prolonged across the UK. There were statements at the time made by senior government ministers that those floods represented a wake-up call for the risks associated with climate change. And at the time I was working for the Centre for Ecology and Hydrology in Wallingford, a national research institution, and we were commissioned with the Met Office by government to conduct a study that would look at this very question: were the floods of winter 2000s, and I think the words used at the time were caused by climate change. And the conclusions we came to were that it's very difficult to link any one specific event to climate change, or at least to establish causality, because of course our weather is very variable, and that natural variability makes the attribution of individual events difficult, and it also makes it difficult to attribute the kind of trends that we just saw on the previous graph to anthropogenic climate change. So we published a report with conclusions to that effect, which was very carefully worded and based on government guidance at the time about the communication of scientific uncertainties. If you could move forward to the next slide, please. This was my first experience of engaging with the media through science. And the day after our report was published, the Times ran an article with the headline "Flooding Baffles Scientists," which wasn't really quite the position that we felt we were taking, and maybe I suppose taught me an early lesson in my career, both about the importance of a communication strategy, and also maybe gave me a few warning flags about interpreting government guidance. But there we have it. That was the headline. If we could move forward please. For me, I think what's really significant here is that over the intervening 20 years, we now actually are in a position scientifically to address the question that was being asked at that time through a branch of science known as extreme event attribution. So this is a type of analysis that uses weather models and climate models almost as a kind of computerized lab experiment to study extreme weather events and to look at how likely they might have been in a world without anthropogenic greenhouse gas emissions. So we can refer to that as a pre-industrial climate. So we were involved in some work led by Oxford University following the floods in the winter of 2013 and 14 that specifically sought to understand the influence that anthropogenic greenhouse gas emissions had on flood risk during those events. And what we found, and one way of looking at this as a kind of shorthand is to say that there is evidence that climate change is already loading the weather dice. So you can think about weather on a month-to-month basis as being sort of quasi-random. It's a chaotic system. Then within that randomness, there is some influence of climate change already apparent and revealed through studies of this type. We were able, in fact, using data from JVA risk management to quantify that influence of climate change in terms of the number of properties placed as additional risk, which was just under 500. It's not a very large number, I suppose, compared to the UK as a whole. It's within a wide range of uncertainty, but these are early indications that we are already seeing climate change fingerprints on flood risk events. And there have been around the world something like, I think, 49 or 50 studies of this type published relating to extreme rainfall and or flooding events over recent years, and around half of those have found evidence of a climate change, global warming, as you might put it, influence due to anthropogenic greenhouse gas emissions. So that's the present day picture. If you move forward, please. I'd like to turn now to future projections. So again, referring back to the UK Climate Change Risk Assessment, which draws together a wide range of data sources. We have fairly clear projections looking forwards based on the usual climate change scenarios adopted by UK government and by the IPCC. And those projections generally indicate increases in flood risk. So the maps that you can see here show the percentage increases projected for numbers of homes at risk of flooding, again using this 1 in 75 annual chance as the definition of risk. And this is for flooding from rivers, from the sea, or from surface water. And these projections assume that we continue with our current sort of levels of adaptation, current levels of investment in flood management, and do not assume any population growth. So, I think that the projections, really give us some clear cause for concern about future increases in flood risk. We can move forward, please. And so I guess the next question is, what can we do about this? Focusing now on England, the Environment Agency has commissioned and for some years now been running a series of what are called long-term investment scenarios. These results were produced with the consultant Jacobs, and it's perhaps a slightly complicated table, but just to cut to the headline figure here, what this suggests is that even under a moderately pessimistic, perhaps, global warming scenario, which would be similar to the 4 degrees C increase in terms of the Paris agreement, and certainly in terms of the +2 degrees C Paris scenario. It should be possible to prevent a further increase in flood risk in economic terms in England through conventional flood and coastal risk management activities. So that means things like investments in physical infrastructure, raised flood defences, flood walls, coastal defences, and so on. But also, importantly, within this, there are some assumptions about the increased uptake of resilience measures on individual properties, so things like floodgates and flood-resistant flooring, and also some assumptions that I think could be described as favourable, maybe optimistic, about our ability to restrict further development on floodplain areas. The other point to make about this is that in order to achieve this kind of level of adaptation, and this is looking at 50 years ahead, we would need to increase the level of economic investment in flood management to a figure between £1 and £1.2 billion per year. If you could move forward, please, Ted. And so this begs the question, are we anywhere near that kind of level of investment? The answer is no, not at the moment, and not in the recent past. These are data on flood management investments in England going back to 2005, and it's been running, generally somewhere between around 600 and a little over 800 million pounds a year. So we're not quite at the 1 to 1.2 billion annual investment that we saw on the previous slide. So we could move forward, please. Just coming to the conclusions now, and sort of focusing back on the ideas around communications that I think we hope to explore in the workshop today and tomorrow. I think one of the implications of this picture is that we need to be having, and indeed are, I think, beginning to have what will be some quite difficult conversations about risk. Following the floods of 2007, Sir Michael Pitt was asked by the government to review flood risk and resilience, and this is quite a familiar pattern in a way. After major flood events, we tend to have a review shortly afterwards. And I chose this quote because it's just so pithy. One of the things that the Pitt Review said amongst its many recommendations is that we need to be more willing to tell people the truth about risk. I think we're back here to seeing really strong resonance with the acute risk unfolding at the moment with the coronavirus outbreak. So we could move on, please. And I'm just going to highlight where I think two of those difficult conversations are likely to focus on. So one is about coastal risk. This is a quote from, or a couple of quotes put together from a report released by the Committee on Climate Change in 2018 about managing Britain's coastline in a changing climate. And the point it makes is that under our current climate change projections, and if we continue with current economic rules around public investment, there will be communities around the coastline, and there will be a substantial length of coastline for which it would not continue to be economically viable to offer protection as is currently planned. So essentially, there are some very difficult decisions to be made about parts of our coastline and the communities, the people and the businesses that live there. And that perhaps echoes some of the points you made earlier about the situation in Miami. If we could move on to the next slide. The other difficult conversation, I think, and it's somewhat related, of course, is that even with continued investments to reduce flooding, there are many people who will inevitably have to continue living with flood risk. And based on the previous iteration of the long-term investment scenarios, Jim Hall at Oxford University published a review that estimated this figure might be around 300,000 people, 300,000 properties and the people who live in them. And the reason for this is partly because, even with flood defences in place, there is a residual risk. Flood defences in general can reduce risk, but they don't eliminate it. They can collapse structurally, or they can just simply be overwhelmed, as is the case here in the photo. And indeed, for many of those of the people living in those 300,000 properties, again, under the current economic rules that we have for investments, it may not be deemed cost efficient, cost effective to offer community flood defences. There is some mitigation available from property level measures, but that might not always be able to eliminate risk again. And although there is now greater access to insurance through the flood re-scheme, again, insurance is, it's a risk transfer, really. It doesn't eliminate the risk of flooding. So people are going to have to continue living with flood risk, and there are some really difficult issues around, again, the equity of that, social justice and access to resilience. So if we could move on, please. So my final slide, Ted, is just to flag up another one of those reviews I mentioned. This is the National Flood Resilience Review that took place after the winter floods of 2015-16. This review was instigated from the Cabinet Office and involved a scientific advisory group that was chaired by the government chief scientist at the time, so Mark Allpost. And as well as some of the technical analysis of flood risk, it also contained a very interesting and useful set of recommendations from a communications scientific subgroup. And I won't read them out. I've listed them here, but I think they're well worth having a look at. It's again interesting to note how many of these resonate with the current situation we're in with the virus outbreak, and very importantly, I think to understand how these sorts of principles of good communication could help to build trust between citizens and the state. So I will leave it there. Thank you very much.